but we'll go ahead and get started here. We've got a decent amount that we're going to cover, and I just want to welcome everybody to our advanced training. We've been doing this now. This is our second time doing this. We're trying to do it, and it's a little bit strange, but we're trying to do it the first Tuesday of every month, unless that Tuesday falls in the first week. And that's mainly because we have a lot of customers that when the Tuesday falls within the first week of the month, that's typically month-end close, and they're usually pretty busy. So we try to schedule around that. But the thought is for the rest of the year, and hopefully for the years to coming, we're going to be covering advanced topics one at a time, going over them for an hour, 2 hours, or however long we need to be able to have our customers and technicians and programmers understand the topic that we're going over. Plus, the topics will be recorded and then turned into videos that will be placed on our website, and also up on our YouTube channel at CRT.Services. So please check out our YouTube videos. We try to make these informative. You'll see that there's some longer videos, but we'll also start producing more short topic videos. And our videos are going to cover not only the FlowX series of flow computers, but also all flow computers. So as you have questions about other manufacturers of flow computers besides the FlowX, let us know. We're going to cover those topics. Today, we're going to be going over calculations inside of the FlowX and how to create custom calculations or user calculations to do some logic that may not be present, but you need to be able to do this logic, let's say for giving permissive to PID control, or maybe I want to activate or deactivate a meter based upon a status input, and that logic may not be in the FlowX. So it's how we can build logic or build functionality that is not built into the applications. A lot what you'll see inside the FlowX is in the applications is that they were changed and added all by customers saying, hey, I need to put a calculation in, and then we add that into the standard as an option. So a lot of customization that had to be done previously over the years has just been incorporated in the functionality in the flow computer. So the need for the writing these custom calculations has become less and less as time has gone on. But if you have examples, or if you have questions about how to do a calculation, some practical example that you may be having come up, or you don't understand how to do, please speak up. Let me know. We've got some moderators on here. Isaac Perez is on. Isaac is just joined our team about 3 weeks ago, and he is a wealth of knowledge. He spent almost 20 years with Omni as their manager for support, but also worked in engineering and has traveled the globe doing training, installations, troubleshooting, and technical support for Omni. And most recently has been with Crestwood, and working on all kinds of different flow computers, from the rocks to flow bosses to total flows. So we have a pretty wide installation base of flow computers for our customers. And what we've decided is we want to help educate customers and also educate users on how to use different flow computers to hopefully eliminate some of the frustration, regardless of the manufacturer, and also help increase the knowledge that users have on how flow computers work, what the proper settings are, because a lot of them you'll see are common, and what some good practices and procedures and policies are that should be in place within your organization for dealing with flow computers. Isaac and I have spent, I think, combined the last 50 plus years working on flow computers in the oil and gas industry, and we both have a passion for it. CRT does as well. So we're here to help out, again, with any of those questions. So with that, next month's topic will be on Boolean and variable statements, working with those inside the Omni. So again, creating logic inside the Omni when it's not part of the firmware or the application. How do we do certain functionality and some of the most common Boolean and variable statements and calculations that we would do? So Isaac's going to spearhead that as one of our topics in April. Gosh, time's really flying by. So we look forward to seeing that. And again, we'll record that, put that online. We're also going to start recording little 5 and 10-minute topic videos. So some of the ones we're going to be doing are, let's say, specific topics on setting up proving, setting up outputs, setting up different functions of the Flow computers. We'll do one on card selection for the Omni 6000 and 7000, what those different cards mean, and try to break that down. But again, the goal is to provide as much knowledge to customers and put it in a place where the information is easily accessible and you guys can get to it when you need it. We don't believe that anything should be hidden, and all knowledge should be available to help out. So we actually find that the more our customers know, the less they really need to call us for support. So it works out for us a little bit that customers feel confident in making the changes, and they're able to utilize the system. So we use this as part of the education in the industry to help advance what we're doing. With that, we'll go ahead and get started. And today we're going to be dealing with calculations. And the calculations I'm going to deal with are going to reference our new liquids application. And in that, the tag names are very specific. But what you're going to find, and I'm going to show some examples of how with the older applications, the tag names are almost the same. They're just a little bit different. And I'll explain to you how we search for those. The FlowX obviously is a tag-based system. So we work with tags internal to the device, and we try to identify those tags to use in the logic or to throw onto communication templates and so forth. And we went over that in our last topic, advanced topic, last month. And again, this month we're going to go over calculations. So with that, what I'm going to do is I'm going to go ahead and open up a couple different applications. The first one I'm going to open up is the new US Liquids application. This is a 2-run application. It's the latest from ABB. And with this, I'm not doing any modifications to it. This is just the way it comes. And we're going to look through it, and we'll go through how to identify the tags we need, how to write these calculations, and also where we can look to find some other information. So with that, I'll get rid of this little logo that we have here, and we'll open up Flow Express. And in Flow Express, I've already opened up, you can see up in the top left, I've already opened up the Liquid Master application. Now, you may be asking, hey, where can I get the latest information or the latest applications for the FlowX? Well, you can get them 2 different places. One of them is our website. And our website you can come to at, let me go back up here. So our website is at CRT Services. And with CRT, if you go to support, and you'll see applications, and we've got a version 4.0, we've got our version 3.0s, but we haven't put the 5.0 up there yet. So we're still doing a little bit of testing here in the US. At CRT, we work directly with the manufacturer, ABB, on these applications. It is officially released, and we're just becoming a little bit more familiar with it. So while it's not here officially on our website, it is in our download section. So I'm going to throw up real quick in chat this link for our website. And please feel free to save that. And that's specifically for the support section. Obviously, if you take out support, that will get you to their homepage there. We also have another site that is our download section. So our CRT download section, and again, I'll send you this link, actually has more information on it. So Flow Express, the application that we're using, the most recent is 3.2.6. And this is the 64-bit version or the 32-bit version. Plus, we have all the archived versions there as well. For the applications, we have the 3.0, we have the Liquid 5.00.2, and this one should have the 2 runs on there. There's also lots of tools and other our documentation, everything that I'm going over today is also inside the documents that we're going to go over for the installation, the liquids application, and so forth. So please feel free to grab all the manuals or drawings or whatever else you need for the FlowX. They're all located up here on our shared drive. If you're looking for some information and you can't find it, just give us a shout and we'll give you a hand in locating where that would be. The other thing that I'm going to show you is our communication template, and that is called the FlowX Liquids 5.02, and this is the two-run Modbus mapping. And what it does is it breaks down in our Modbus section what all the different FlowX functional names are, what the data type is, what the description for those is. You also find a breakdown of how a tag is, meaning that the common abbreviations associated with tags and how we build a tag and try to decipher a tag to find out where the information is. And just some examples of this, and we'll be getting a lot into this a lot more. And then this actually has our standard Modbus mapping for the FlowX. This is called internally in the FlowX. When we look at our ports and devices, if I'm putting a communication template up, this is just called our tag list. So this is our Modbus mapping. And again, this is available and it goes over pretty much everything that's inside the FlowX, what register there are, and then what tags associated with it. So if you have questions about using that standard Modbus list, again, let us know. It's 425 pages long of tags and Modbus registers and data types. So you can load that up and run that in the FlowX, and you already have a pre-built map inside of it. And we will, again, that should be on our download section. So what we're dealing with is we're going to deal in a section of the FlowX that's called calculations. And calculations were meant to be able to build tags, build commands, or build logic in the FlowX that isn't inherent to the application, but allows you to do, again, some of your own custom logic. Now, this logic, a lot of it is just simple Excel logic. If, and, or those type of statements and so forth, you can utilize that terminology or verbiage inside. So let's do something as simple as let's set up where we have a digital input, and we want to look at the status of a digital input. And when that digital input is high, we want to set a digital output high. And when that digital input is low, we want to set a digital output low. Now, with this, we can, there's a bunch of different ways that statement can be written. And if it works, there's not necessarily a wrong or a right way to it, because there's, like, again, there's several ways that I can do this. So for simplicity, let's just make this really, really simple. We're going to go ahead and we're going to say that we're going to look at digital 1. And when digital 1, the signal state of it goes high, we're going to set digital 2 on. When the signal state is low, we're going to set digital 2 off. So the first thing I need to do is, when I look up top in my calculations, you'll see that we have the ability to have new tags, new parameters, new alarms, new write values, and a new group. So a grouping is just basically a folder to try to organize if you have a lot of calculations. So you can put a new group in there and name it digital out. And then below that, I'm going to start building some logic. And again, you can put help descriptions. There's a lot of information that you can put inside this. Before we get too far, one of the cool things that I want to mention about this is these calculations. When we build a whole folder of calculations, we can import these to another application or another program that we have by simply opening both applications up. So I can open up 2 versions of FlowExpress or 2 instances of FlowExpress, hit copy, and then go over to the other and just hit paste, and it will go ahead and paste that in. Now, it's giving me a bright red because that means that it has an error, and it'll tell you that, hey, this is a duplicate, basically. You can't have two folders with the same name. So as soon as I change that to digital out 1, let's say, you'll see that that goes away. So anytime we see red, it's not good. So I'll just take that out. So what I want to do is, again, I'm going to write when a digital 1 goes high, I want digital 2 to also go high. So what I'm doing is I'm going to do a new write value because I want to write to the digital output. So I'm going to hit write. And the first thing it's going to ask me is the name. What do I want to write to for this calculation? Well, I want to write to digital 1. Well, how do I find where digital 1 is? All of my tags are listed down the bottom here. And you can see there's 42,000 on the right-hand side. It shows that there's 42,870 tags in the Flow computer. So now we just need to sift through them and figure out which one's for digital input number 1. In the center, off left center, you'll see that there's a tree view. So the tree view breaks us into a hierarchy. So when I click on the tree view on the left-hand side for the module, I now have a hierarchy. And I want to go in and I'm going to look for digital outputs because the first thing I want to do is I want to find out which digital output I need to set, which is going to be number 2, because that's the condition I want to write to. So I'll go to IO, I'll go to digital outputs, I'll find digital output number 2, and module 1, digital output 2, signal state. This is what I want to write to. So I'll drag that and put it up top. So I'm going to write to module 1 signal state. What's the value I want to write to it? Real quick, over on the right-hand side, you're going to see types. And you can see this is a set on condition. There's also a set on change and a set on event. Right now, we're going to start with a set on condition, and we'll go through each one of these and what they mean. So the set on condition is, provided that the condition down here is true, I'll go ahead and set that. And let's do an example of, I want to look at the digital input state of the digital 1. So I'll go to digital IO, and now I can look at the signal state, and I find digital 1. So the signal state. So if I say the condition is equals 1, and I put a 1 for the value, what'll happen is it will go ahead and when the digital 1 signal state becomes high or a 1, it will write a 1 to the output. As long as that's true when you put it on set on condition, as long as that statement is true, then it's going to write that output. If the statement's not true, it's not going to write a 0, or it's not going to write a 1. The problem with just a simplistic output like this is that we said, well, okay, if it's 1, then it's going to go ahead and write a 1. But when it's not 1, the last thing it wrote to was a 1. It's not a 0. So I would have to write another statement that said, well, and we're going to basically, I'm going to create a little copy of that, and we'll paste that in our folder. And you could write this equals 0, and now write a value of 0. So now I have 2 logic statements. If it's this, write a 1. So if it's high, write a 1. If it's not high, write a 0. And this logic would work perfectly fine. But let's change it up. We're still going to do the same thing. But now what I'm going to do is I'm going to say, always write whatever value I have. But now I'm going to write an if statement. So I'm going to write if the digital 1 signal state equals 1, then go ahead and write a 1. If not, write 0. It's a set on condition. So the condition is a 1, meaning that it will always write that. And it's simply going to look at digital 1 as using a simple if statement. If it's 1, write 1. If it's not 1, write 0. I could write any value that way. I could write 2, 3, 4. Again, it's a simple if statement. So that's a second way that we can do the same exact function. Well, what if we did it a little bit different? I'll go ahead and I'll remove I'll leave the condition of a 1 in there. But now I'm going to tell it, hey, you know what? Let's just keep this even simpler. Let's just look at digital 1 signal state. So now if digital 1's high, digital 2 will be high because I'm always going to set it to whatever digital 1 is. Again, I don't need an if or anything else as long as it's 1 or a 0. Now, what if I needed to inverted the logic? Then I could put an if statement in front of it and say, okay, well, I need to reverse the logic now. I can say if digital 1 signal state equals 1, I want my output to be 0. If it's not 1, then then set the output to a 1. So now I've just done a little reverse logic. Let's build on this. Let's build, and what we're going to do is we're going to make this where digital 2 or digital 1, when that's high, that'll set digital 2 states to a 1. But when digital 3 goes high, we'll set digital 2 to a 0. Now, we would have to look at we'll make this a little bit more complicated as we go along because that's pretty simplistic. But I want to show the simplicity behind it, and then we're going to get a little more detailed. So basically, I have my first command. But now what I'm going to do is I'm going to change it not from a set on condition. I'm going to set it on an event. An event is a Boolean trigger that goes high. Or it's a logical statement that is true. Again, meaning that that statement is high. So the value that I want to write is going to be a 1. And I can put a help description in there. What's the event, though? Well, the event's going to be digital 1 signal state equals 1. So when that goes high, set the digital output state to a 1. But it has to go high. I have to see it go high. If it stays high forever, I won't keep on writing a 1 there. It's a one time until the statement becomes not true and goes true again, and then I'll write it again. And you can put an enable logic in there. So I could put a tag in there that says enable, disable. So as long as it's enabled, it'll do this function. If I disable it, it won't do the function. So I'm just going to leave it as enabled all the time. And when the digital goes high for digital 1, digital 2 will go to a 1. Now I'm going to copy this, put it in here, and now I'm going to set another set on event. This time, the set on event is going to be go to a 0, but I'm going to look at digital input, and I'm just going to change the digital input up here from a DIN 1 to a DIN 3 to look at the digital input 3 state. So that gives me my digital 3. If that goes high, then I'm going to set digital 2 to a 0. So what happens, though, if I look at this logic, that's going to work fine. But what happens if I have digital 1 also high? Do I want to be able to set this to a 0 if digital 1 is still high? Maybe I don't. So now I can put in a little bit more logic. So the event can be an end statement. So I don't want to set this to a 0. I want the event to be that the mod 1, digital 1, signal state is a 1, and digital 1 signal state is 0. So now I have two conditions in that event. And as long as both are true, if one's not true, then this whole Boolean statement is not true. So now when digital 3 signal state is a 1 and digital signal state 1 is 0, I'll go ahead and write a 0 and reset the output state. The same way here, we can put an end statement in front of that. And we would look at digital 3. So as long as digital 3 is a 0, we'll set digital 2 to a 1, provided digital 1 goes high. So a little more complex, a little bit more functionality. So that's when we do a set on event. What if I wanted to set digital to if either digital 1 or 3 are high? I'm going to go ahead and delete this. Now I can do it as an event or I can do it as a condition. Now, if I do it as an event and both of them are high, it'll set the triggered output one time, but it won't set it all the time if it remains high. So for some reason, something else sets it low, it won't set it high again. So maybe I put that in my logic that says, hey, you know what? If it's not this, then go ahead and make it high. But first, let's do something simple. We're going to do set on condition. What are we going to set? We're going to set digital output 2 to a value of a 1. When are we going to set it? We're going to change this to or. Or mod 1 signal state is a 1, or digital 3 signal state, oops, not a 3, is a 1. So now if either of these are true, it will set this high. Now, what happens though if digital 3 is high, but digital 1 is low, and then digital 1 goes high? Nothing, because digital 3 was already high. Therefore, it's constantly writing, because it's set on condition, it's going to constantly be writing this 1 value to the signal state. And again, we could put logic in here that says, okay, well, now I don't want to write just a 1. I want to write either a 0 or a 1 based upon a selection. So we start writing if and or and so forth in there. And again, we just keep on building on the complexity of this logic that we're using. So right now we've done or conditions. We've done some end conditions. We've looked at 2 different states to set a digital output using the set on condition or set on event. Well, let's do a set on change. So now, if either of these change, and I'm just going to leave it the way that it's written for right this second, this is basically saying that if either of these change, or, and I can change and take out the equals. So when either of these change state, it's going to go ahead and set a 1 to the digital output state. Now, that's because it's looking for a specific change. We could have this be pretty much anything. I could look at a totalizer. I could look at a process value. I could look at something else that's being written to me, And when I see a change in that state, regardless of whether it goes to a 1 or to a 0, it would go ahead and set that signal state out. And again, we can just keep on building on that logic. What if I wanted to, on this digital 2, what if I wanted to set an output by having a user input? I want a command that sets the digital to a 1 every time I hit this button. Well, we would create a button for doing that, or I could look at another button that's in there. Let's do something like we're going to create a new command. So what I'm going to do is I'm going to stay on digital out, and I'm going to create a new parameter. And that parameter, I'm going to call it, this is a tag name that I'm creating now, I'm going to call it the start command. So this is the tag name, if I could spell, _CMD. So I'm just start command. The text is what's going to be displayed if you put it on a display. Start pump command. The value, well, the value is going to be a 1, or I'm sorry, it's going to be a 0 to start off with, because when I issue the command, it's going to put it to a 1. So you can put in minimum, maximum, and then write levels. So in this case, this is going to be a write level. I want the user to have at least a level 500 to be able to do the write. This is going to be can be a Boolean, it can be an integer, it can be an enumeration, it can be a unit of something. So we can change, again, enumerations. It could be a drop-down selection or something else that's in there. It can be a unit. Or it can be a Boolean. And we're going to leave it as a Boolean. The format is, again, you could write a format for it. The help descriptor, this is going to be what would show up as a help icon over top of the tag. And the UI mode is either a command or a command without acknowledgement. So a command without acknowledgement would be I hit the button and it does what I say. Or if I just hit command, then it will prompt me when I hit start, and it'll ask me for confirmation that I actually want to start it. So we'll leave it a command with acknowledgement. Now, the logic sequence in the calculations is that if I'm using a tag in logic, it has to be sequentially before that tag. So I'm going to use this start command. And basically this start command, we can go ahead and we're going to, the start command is fine. Sorry, lost my brain for a second. So we're going to do a start command. We're going to do a change on event. And the event is going to be this new start command. So when I start typing start, you'll see that my start command comes up. So now the event is when the start command goes, we'll write a value of a 1 to the digital output state. We'll set that output. We could also then copy, and I'll put start command in here again. I'm going to move it up, but now I'm going to label the stop command. And this will be a stop pump command. It'll issue a 0. And again, it's a command with a write level of 500. It's going to be a Boolean, and it's going to go ahead and write a 0 to that when we issue the stop. So I've got a start, a stop. So the start command here is going to go ahead and put it as a 1, which means I need now to copy and again paste. And now I'm going to set it to a 0 when I issue a stop command. The last thing I would do is I would add the start and stop commands to my displays. Now, when I add calculations to my displays, I have to bring them basically somewhere in the display, either before or after. And what that means by before or after is this is the US liquids display. And I'm going to go into a preview, a little user interface here. And give me 1 second when this comes up. So what that means before or after is it's either going to put it before this in-use value or after the system value. So we can go ahead and let's just add it in after. And what I'm going to do is I'm going to create a new display. We'll call it pump commands. And I can select a little image here, and maybe I'll grab an image of a pump. And then inside of that, I'm going to place tags. And again, the tags, I'm going to grab a pump just so it looks nice. Maybe call that commands. And then we need to find those new tags. So we had a start and stop. Now, these are calculations. So they are start with a CALC. And if I type in CALC, I get tons of calculations. But if I put an exclamation point and hit calc, you'll see my start and stop commands are there. So I'm going to go ahead and put them up. And I'm going to check this little new line. And what that does is in the display, it creates, puts these on separate lines on the display. And I'll show you what that looks like. So now I'm going to preview my user interface. At this point, before I did the preview user interface, I would have also saved the application. But since we're just going through and doing a bunch of different functions, and again, this doesn't let you, this environment that we're in right now, this preview user interface, this is only showing you what the interface is going to look like. We can't change parameters or do anything here. It's just, again, showing you what it looks like once it's going to be loaded up to the module. So with pump commands, when we look at that, you'll see that we have our start pump command and our stop pump command. We have our little start pump command text and stop pump command text. And if I was to go into calculations and go on both of these commands and then type in a help topic, let's say on the start, when pressed, the pump will start. So give that detailed help. That should really help somebody out. And again, I'll go back now and look at my display. Wait for the preview interface to come up. And one thing you're going to notice, I don't know if you see this little stop command that is up here in the preview interface. This is actually a bug in FlowExpress graphics of this environment. You may see this stay up here. It doesn't affect the logic. They're working on trying to get this out, but every now and then when you do something, it will show up like this. So if I hit now my pump commands, you'll notice that help descriptor has a little I. And that's how you put a help descriptor in as well. Now, the functionality that we've added in has not impacted our normal operation. It's just additional functionality that was built in. So we can start and stop a pump if we want to. Again, somewhat simplistic, but there is a lot of functionality that you can do with this because you can really get complex in how you're starting and stopping and so forth on the outputs. You can build a really complex logic sequence inside of here. And we've done it for sampling systems and things like that, where we just build these calculations. And it certainly helps out with functionality inside the Flow computer that, again, may not be present. So we've got our start and stop commands. Again, now that this is a full folder, I can copy this whole folder and paste it into another application and use the same logic there. I'm just going to fold that up. We'll leave that logic in there. And the next thing we're going to look at is setting an analog output, or setting an analog input, or using an auxiliary analog input or something else as my temperature, let's say for the meter run. So we'll go over a bunch of those different scenarios here. When I look for tags within the Flow computer that have to do with custom functionality, they have a common name associated with them, and that name is basically, it's a custom val. And what we're doing is, if you're familiar with some of the other Flow computers, maybe you're writing to a scratch pad or something else. In the FlowX, we're writing to a tag that's used to hold a custom value. And then we can determine if inside the logic, we want to use that custom value as our process value. And let's just use something as simple as meter temperature. When we go set up the Flow computer and we get into the meter temperature, and I'm going to do it through this little display here and previews the user interface. Again, I'm not going to be able to actually set the values, but I want to show you the choices that you have. When we go into configuration and we're setting up a meter run, we have our temperature. And you'll see right now the temperature is set up to always use the override for meter temperature A. Now, you can have multiple temperature transmitters coming into a single run on the FlowX, and you set that up somewhere different, but we're just going to leave it as we just have a single temperature transmitter come in. Now, our options are to use the analog input value, to use a PT100 input, an RTD, to get it somehow off of communications or Modbus. So if I was using, let's say, a Coriolis meter or a smart meter, if I selected Modbus, I could get it off a custom communication sheet, or I could say off a smart flow meter, it would know to go look at the micromotion or the ABB, Coriolis, or ultrasonic and take the temperature from there. But if I'm going to write to a calculation, a scratch pad, we call them a custom value. So when I say use a custom value, it automatically knows then, hey, I'm going to, and again, it's not going to do anything here, but I'm going to go ahead and look at that tag that you have for meter temperature A, and it's called custom value, and I'll use that as my temperature. And you can see it switch back to always use override, because again, we're just previewing that user interface. If I actually wanted to set it, I would go into parameters in this menu, go into configuration again, go to the run, go to temperature, and now I would tell it, hey, use custom. And here it would actually use custom. I would have to write this change down to the Flow computer, because again, with Flow Express, we're never live with the Flow computer unless we are writing down to it or reading back from it, or we're in the online mode. Everything else we do with Flow Express is offline, and then we write those changes to the Flow computer. Now, normally with the parameters, again, I would do this in the web interface live, but I just changed them here to show you where we're going to be writing to. So I'm going to go back to calculations. And now what I want to find is I want to write a new value. And what do I want to write? Well, I want to write, let's say, my meter temperature. And again, this is just to keep me organized. And it's going to be a new write value. What am I going to write to? Well, I want to write to the meter temperature for run number 1. So how do I find it? Well, I'm in my tree view. So I'll go to module 1. And I'll look down here and see if we have anything for temperature. And I may see meter temperature. Oh, there we go, meter temperature. Now, unfortunately, that doesn't give us what we're looking for, because that's the upstream and downstream values. It's not actually in the temperature setup for meter A. So we'll see if we have something down here for just temperature. Okay, we've got temperature, and we've got meter A temperature. And you'll see that we have everything from a command for a calculation to the one I'm specifically looking for is custom val. So custom value, if I write to that and I put the meter temperature A to use custom, it'll use whatever value I write into this. So I'm just going to take this custom val and put it up top. Now, what if I didn't know kind of what I was looking for? I know it's a custom value, but I'm not sure which one it's on. I can list out, if I click over here on the list view and just type in something like custom underscore val, then it's going to list out in the Flow computer all 56 custom values that can be written to, whether they're for differential pressure, whether they're for viscosity, BS and W, and so forth. But these are all the different custom values you have for the processes. So we already selected that we're going to use custom val for the temperature, and I want to write to that. Well, what do I want to write to it? I want to write, let's say, an auxiliary. I've got an auxiliary transmitter coming in, and I want it to use that value that I have set up. So again, I'm going to look for the auxiliary. Let's say it's auxiliary analog input 1 or auxiliary temperature input number 1. But we're going to go ahead and we're going to go to our tree value, go back to module 1. We'll go down to temperature again, since I already know I have, let's say, an auxiliary set up. So an auxiliary temperature. And I can look for the auxiliary temperature current, which is going to be CUR. And I'll take that and I'll say that that's the value. It's a condition. Well, I can write a 1 and it will always do that condition. So every calculation, it'll write it. But what if I want to make sure that in this, that the auxiliary temperature transmitter is actually still working, that there's not something wrong with it, that it doesn't have any alarms? Well, I could add in a condition is then the alarm status. Now, alarm statuses in the FlowX have they're basically it's a bit status built in. So a 0 means that there's no alarms, and then typically if you have a 1, a 2, 3, 4, or 5, they're going to equal that it's either in the low for a 1, high for a 2, low for a 3, high for a 4, or rate of change for a 5. I'm going to say as long as the condition for the alarm status is 0, then go ahead and write this. But if I have an alarm come in, transmitter fail or something else, don't write that value. It'll stay at what the last value is. And again, you can get more complex. You can say, well, you know what? I don't want to write it if the values are greater than or less than these two other values. So what I'm going to do is I'm going to, put that in there. I'm going to look at that value, and I'm going to write an end statement in here now. So I'm going to say end. So number 1, there's no alarms. And there's not 2 A's in end. So there's no alarms. If I hit a comma, I also want where if the auxiliary input value is less than or equal to 20, and that input value is greater than or equal to 1. Or I could just say greater than 0, that would be 1. So I've got as long as I'm greater than 0 and I'm less than 20, it will write that. Now, obviously that's not realistic, but let's say I'll make this 120. So you can write a value like that, and it'll write it provided that this is true. what if I needed to, I don't know, what if I wanted to change it and write an override value? So I want to write that TT custom value. I want to use the live unless this is true. And if that's true, then I want to write an override value. Again, there's a bunch of ways that I could do this. We could write the logic to also say that and put an override value in there that was changeable. But what if I wanted to just, we'll keep it simple and I just want to hard code the override value. Well, what I'm going to do now is I'm going to come up here and I'm going to add this. So instead of writing the whole current value, I'm going to say, what value do I want to write? If this is true, this whole long end statement is true. This is one big if statement. If that's true, I'm going to have you go ahead and write what the current input is. If it's not right, if that condition is not true, then I want you to put in a value of 45. And you can see here, it's telling me if the logical test. So if it's true, it's going to use the first value. And if it's false, it's going to use the second value. I end that up. And now I can come down here and say, well, the condition is always true. So depending on, it's always going to write to it, but now it's either going to write what the current value is, or it's going to write an override value. And let's go one step further now. And let's put in a new parameter. And I'll put that new parameter up here. And I'm going to call that new parameter temp override. Temperature override, O-V-R-I-D-E, spelling's leaving me today. Help description, we won't worry about it. I can put it in a minimum and maximum, but the value I'll start off with is 45. So now instead of hard coding it, I'll tell it to use the override value. I call it temp. So now, if that's outside the range that I'm specifically looking for, I'll use whatever we programmed in our override value. And then I'll take that temp override. I'll go to a display. And I think I'll just put it back on the same one we just created, the pump commands. And now you'll see, because I've listed everything here on the calc sheet, that new temp override value. And again, I'll do another line. And now we'll preview that user interface. And when I look at pump commands, there's your temperature override value. And now we've got an override value that a user can enter. The end goal of everything that we're doing here is to create logic that's doing something that is not already available inside the Flow computer. But also part of that is I'm going to make sure that I have an interface that's logical, that my users or operators or somebody following behind me understands what they're doing, and whether that's adding in more help descriptors or logically arranging it, or even trying to call the name of whatever that tag is a logical name so people understand what it is. So this is some simplistic calculations on how to do simple inputs and outputs, but they can be as complex as you want. And these examples are looking at an analog input, but what if instead of an analog input, I actually wanted to look at the value that was being written to me by some other device? Well, I could create a holding value, and let's say that holding value is this temperature override. I could put this on a calculation sheet, this tag, temperature override, and use it as Modbus, because this tag internally in the FlowX now is called calc, C-A-L-C, exclamation, temperature override. How do I know that's what the tag name is? Well, because it's in calculation. So any new tag that I create in calculations is going to have the CALC in front of it. I can also look at the display I just created, and it tells you that tag name in the center there is calc exclamation temp override. So I can use that same name, and I can put that on one of my communication sheets. And if something writes to it, it would change that value. So I'm calling it temp override. This is just basically could be used as a holding tag as well. So something could write to it because I made it writable. There are a lot of other tags inside where, again, a new tag that's not writable, I would create a new tag, and that could be the function of math or something else. Again, you can do math inside of this. You can do complex calculations inside of this. We're going to get into a couple more after we take we're going to take just a brief 10-minute break, grab some coffee, use the restroom if you need to, and we'll start back up at 10 after 10 my time, but in 10 minutes. And then when we start this off, if you have any questions, please let me know, and we'll go over some of the questions that you have, or if you have some logic examples in the second little segment, we'll go over those logic examples you may have. But again, please feel free to ask any questions, and we'll see you in 10 minutes. If somebody can unmute and just let me know you can,
Yeah,
that would be great.
I can hear you.
Perfect. All right. And I apologize if I'm going through really fast. I am on my fourth cup of coffee, and I just really enjoy the heck out of this. So let me bring my camera back up. We're back out on the LAC unit in the field. Okay. So the last couple examples that I wanted to give you have to deal with two things for P&ID control. And again, it's not necessarily that you have this particular logic that you need to do, but just examples of how we do some of the logic and how you're able to create some logic inside the Flow computer. So one of those is that when we have when we set up in the Flow computer a P&ID function, let's say for flow rate and pressure control, and I'm going to go into parameters to show you what those settings are. When I go into configuration and I go into the individual meter runs, when I go to the setup, you'll see that I have the ability on each one of the runs and also on the prover and on the station to have flow and pressure control. And you basically can do in the selection flow control, pressure control, or a combination of flow and pressure control. So each meter run has this, the prover has this, and also the station. So you can utilize a bunch of different functions in doing this. I'm going to say we're just going to do flow and pressure control. So once I do flow and pressure control, this also gives me some more settings to do all of my proportional, my integral, my gains, and so forth. What we're going to look at, though, is our permissive settings, because we don't necessarily want always to have the control valve working. Maybe we don't want that control valve to work sitting there ramping up and down if we have a valve to a tank or to a cavern or something closed. So the permissive may be that we're looking at the state or a condition that if that's true, then let the control valve operate. If not, then go ahead and disable the control valve or take away the permissive for the control valve to run. Now, when you take away the permissive for the control valve to run, what it's going to do is it's going to go to an idle state. And you can put in what's that idle state need to be. And we've had customers that are like, hey, I want to put this idle state at 70%. So as soon as I get permissive, I'm already 70% open or 70% closed, or vice versa. Or no, I want it to fully open or I want it to fully close, depending on how you have that. So we're going to use a custom permissive for this. And you see that we have a setting that says use custom PID permissive. So when I use the custom PID permissive, I need to write to that custom PID permissive bit. So I would go ahead and turn this on. And then I need to write to that custom section using a calculation. So again, I'm not going to take out what I have here. I'll just create a new folder, and I can put that as PID run 1. And with that, whoops, it doesn't like that I put PID run 1. Sorry about that, because I use it as a tag, not as a, so we'll just delete that out. I wanted to put a folder in and I put a tag in by mistake. Let me close this, and then I'll pick folder this time, and we'll put PID run 1. So now I need to find what the what that permissive is. So again, I know it's custom, so I could look for the keyword custom, and I'll show you if I'm searching for a keyword. I'm going to go back over, and I'm going to search for custom here. Now, if I just search for custom, you'll see that I do get custom values, but what you'll also see is I start getting customers. So how do I clip that off? Well, most of the custom values that I have an underscore. So I can just put an underscore in there, and that will eliminate and get me down to 236 different choices. And again, as I start looking through here, you'll see that I have everything from temperatures and custom input failures to pressures and so forth. And what I'm looking for, obviously, is my PID control. So I'm going to have something in here for run 1, run 2, for PID control as well. I know that I can also look for the word permissive, so I can just type in permissive, or I could do PID underscore perm, and then I narrow it down a little bit more. So you can see I've got proving PID permissives. The one I'm looking for is this one, the custom PID permissive. Now, this is a tag that we're writing to. It's not a parameter. The parameter where we selected to enable it or disable it is there. But this is the actual permissive value I need to write to. So we're going to create a write value. And that new write value is going to be, we're going to write to that permissive. It's as simple as writing to an output at this point. Well, what do I want to write to it? Well, I can write to a value of 1. What's the condition? Well, I could look at a digital input again, right? So I could come and say, okay, well, I want to look at digital 2 signal state. That's a digital output. Let's look at the digital input signal state. So not from the start and stop commands. So again, I won't look here. I'll go back to my view. I'll go into mod 1. I'll go look at my IO. And I'll come down here and I'll look for inputs. I have pulse inputs. I have digital IO. And we'll look at our digital input. We'll look at signal state 2 for my digital input. So let me click on here first. And the condition is that digital input to state is a 1. So as long as I see that high, we'll go ahead and give the permissive, and the PID will function. If it's not, then we'll put it as a low. I've done it for LACs, where the pump start is my permissive, or a valve open status is my permissive, but it's still just a digital input. Or I can look at the valve status logic and look at the valve status by a signal state or a condition state. So there's a bunch of different things we can signal that off of. But again, keeping it simple, we're going to do this off of the custom permissive value. So unfortunately, I put my little folder out inside my meter, or no, this is fine. I'm sorry. I did not put this inside. So I'm just going to drag it and put it inside my PID folder. Now, what if I want a if I want, instead of to control off of a set pressure, because the PIDs have set points that you can have somebody write to, what if I want to write a custom condition, and I want to use, I want to make sure that I just as a minimum that I'm going to put my set point that I want to maintain the equilibrium vapor pressure. Well, what I can do is I can, again, write another write command. So I'm going to do another write value. What am I going to write to? I'm going to write to the custom condition for, or the custom value for the PID loop. So we'll search again for custom, and we'll go to value. And then we're going to look for our PID custom value down here and see if it comes up as this. And I don't see it in here. So we're going to do a little bit more investigation of find out where that is. So let's go to PID underscore, and we'll start looking through. So we've got our PID, we've got our control. This is all on the prover because it's under an LU Pro. This is all for the run now. So you have a pressure set point. So we could just write to the pressure set point if we wanted to keep it always at what the equilibrium vapor pressure is. Or we could write to the minimum and max values that we would allow it to be. We could say, okay, the control output max limit, or if I have a, if I'm doing flow control, then my pressure set point is going to be what my, either I'm holding a minimum pressure or a maximum pressure. So let's just write this then. We're going to write this to my pressure, and we're going to write it to the pressure control set point. So we're going to write our pressure control set point. What's the value we want to write to it? Well, we want to write the, let's write the equilibrium vapor pressure. And why would I want to write that? Well, I'm dealing with trying to maintain some back pressure for my propane delivery. And I know that as temperature, pressure, and density change, the point at which the propane is going to flash is going to be different. Summer is going to be, obviously, I'm going to need to hold more pressure because the product's hotter. And in the wintertime, I can hold less pressure because it's the product temperature is lower. So let me put this inside our little PID folder here. So the value I'm going to write to it is I want to write the equilibrium vapor pressure. So I know that for equilibrium vapor pressure, it's going to be PE, and then I want the current equilibrium vapor pressure. So I always want CUR. And when I hit enter, it's going to give me for the prover, for one run, run 1, run 2, and also for the station. What I want is the equilibrium vapor pressure for run 1. When do I want to write it? Well, I'll write it all the time. Or I could say write it if it's enabled, or write it if the pressure is above X or Z. So this will write my minimum pressure set point of what the equilibrium vapor pressure is. Problem with this is the equilibrium vapor pressure, if I keep it just at it, then the minimum pressure I'm maintaining is the boiling point. So what I want to do, though, is I want to maintain it at 25% higher. So now if I add in the equilibrium vapor pressure and I put in an asterisk to multiply it, and I want to multiply it by 1.25, it will go ahead and multiply my current equilibrium vapor pressure, add 25% to it, and that'll be my pressure set point for my PID loop. And again, we can put conditions in there that say, well, you know what? I only want to do this when the meter temperature is above 60 degrees. So I could say, okay, well, we can use an if statement. So I'm going to use an if statement, and I'm going to say if the if. Now, what's my if statement? It's going to be my temperature. So I'm going to put in TT, temperature, current, and I've got my master meter temperature. I've got my prover meter temperature, and then I've got my run 1 meter temperature and run 2. So I want this to be my run 1. meter temperature. So I'm going to put this, try to slide it in there. It didn't work. So let me cut this and we're going to put it here. So we'll add our comment in. So if the meter temperature, so the LU run one, the run one TT underscore current, if it is equal to or greater than or equal to 60, then use the equilibrium vapor pressure calculation that I have. If not, then just use a 115 pound back or 115 pound back pressure. Or that could be an override value that you put in for an override. And that's, it will go ahead and do this every single time, every calculation cycle, every 500 milliseconds. It'll update that PID loop with what its set point needs to be, provided that the current temperature is greater than or equal to 60 degrees. So you can imagine there's a lot of different calculations and functions that you can do inside the Flow computer. You're not really limited by what you can do. There's a few things that you cannot do inside here. That the functionality is just not in the basic calculation function. So, and that's things like build timers and so forth. So if I needed to build timers, I could build them in the professional mode using the custom sheet and build calculations inside there that way. But 99% of the time, what we're trying to do is we're going to be able to create a calculation right here by using these calculations. And again, I can zip these up or close them up. And then if I needed this same logic in another Flow computer, I can simply copy it and paste it over. Now, I'd mentioned before about applications being, this is the new version of the application where the run one and run twos, the meter runs are all in the main application. They're not modular based, meaning that the tags, and I'll bring up a little notepad here real quick. A normal tag, I think I just have a regular notepad. I don't want Notepad++. There we go. So if I take the tags that we have right now, and let's take that meter temperature tag that we just looked at, you'll see that it's called LU underscore run one, exclamation, run one, underscore TT underscore current. So if it was run two, then obviously that would be run two. If it was on the station, it would be on the station. In the older applications, the runs were broken down for each module that you had. So once we built the ability, or once ABB put in the ability to have two runs, they changed it where the runs were not modular based, they were based on the application. But again, the previous ones were based upon being on a module. So that tag, that same tag for meter run one, which is on module one's temperature, would actually start off with identifying which module it's on. And then it's LU standing for liquid units. And it's on run. And then an exclamation point, and it would be TT underscore CUR. So in the older system, the run sheets were modular based. In the new system, they're not modular based. Now, what about station? Well, there's only one station. So a station is always LU underscore STN. The same way with the prover, there's only one prover sheet, and that's LU underscore pro. It's really the runs and the IO is always modular based. So all of the IO will always be mod1 underscore IO, and then an exclamation of what the tag is. And again, we can see that when we go to the digital out, you'll see that it says module 1 IO D out 2. But you'll notice that on things like the temperature, again, there's no module in front of it. It's just the LU run 1. Well, that's the examples I have. Are there any questions, or are there any examples you'd like me to go over on how to do a functionality inside the Flow computer? Something that may not be there, or if you have a general question that we can answer, let me know any of those. So I'll go ahead and you can unmute, and if you have any questions, shout them out. Okay. Well, I appreciate everybody taking the time this morning to join in. We'll go ahead and process this video and then get it up online on our YouTube channel for reference. If you have any questions, if you need some more examples or something else, or anytime that you need help with the FlowX, please feel free to go ahead and get in touch with us. The easiest way to get in touch with us is to call our office number, and I'll put that up in a second. You can also, we have a support ticket system, and if you send an email to service@crt.services, it will go ahead and issue a support ticket to us. On our support homepage, you can create an account, and we have a knowledge base, and you're able to submit tickets for yourself or for your organization here. You're also able to access any open work orders or help tickets that have come in from your organization. I'm going to go ahead and chat this link up here also. But yeah, this is a great place. If you need to, if you have products that are damaged and you need to submit an RMA, we have an RMA section as well. And we can get your product, get you a return authorization, and get working on getting the failure, if there is one on your module, corrected. And like I said before, if at any time you have any questions, please don't hesitate to call us, and we will answer any questions that you have. Visit our website. It's pretty long, but if you give us a call at 713-242-1190, that will hit our office system, and we have a support section in there, and that will get you to the right person, or the on-call person to be able to answer any questions you have. We appreciate you taking the time to come in, and if you've got some ideas for other topics you'd like to discuss in some of our upcoming sessions, please go ahead and submit those to us. And if you're in the Houston area next week, we are doing our free basic training class. It's a 2-day class, and that's going on Monday and Tuesday next week. And then we'll do another grouping of free trainings for basics in the next quarter, and we'll send that information out to you. So thank you,
Brent.
Have a good day.
Brent,
yes.
Brent, I do have one question on that PID loop example that you were using with the pressure set point. And you were just taking the equilibrium vapor pressure and multiplying it times 1.25.
Yes.
Let's say instead of multiplying it times 1.25, I just wanted to add 80 psi to the equilibrium vapor pressure, make that my PID pressure set point. All I have to do is change that to a plus 80, right? And that's it.
Plus 80. That's it.
Okay.
And that'll add that up for you, and it'll add that value to it. So yeah, and again, that value now is hard coded, meaning that I would have to write the application back to it in order to change that from an 80 to a 65 or something else. Or you can create, just like we did here with a temperature override, we could create the same thing for a equilibrium vapor pressure set point override or addition value, and that 80 then becomes a tag, and you put that on a display, and then you can change it via the web interface.
Mhm.
Ultimately, that's what I try to do for everything, is because we know a lot of things are changing, and you don't want to have to write the application back down to it. So it's easier just to create that second tag, like we did for the temperature override, and then put it on display so somebody can change it coming into the displays.
So whatever they key in on the display is not going to affect what you wrote in here for the plus 80, right? It's not going
That's
to be a conflict.
that's right. It wouldn't be a conflict because in here, I just wrote plus 80. It isn't until I actually use a tag, and let's say I used that temperature tag for some reason as my override. And this is just an example of using a tag that I created.
Mhm.
So this would take the equilibrium vapor pressure, and then whatever I have in that display, here it would add in 45 instead of writing 80. So whatever I changed here would come in and in that calculation, because again, I put it as a tag, would change the value here.
Right. Okay.
All of these calculations, I typically use the debug offline mode to check them, because when I do the debug offline, it also has a little function as a pop-up that's called calculation, and it will show you all your calculations and what the results of those calculations were.
But if you happen to type the like right there on the value line, if you happen to type something incorrectly, when you're typing that and you hit enter, it checks it as well, right?
Correct. So let's say up here, as for some reason I got this tag wrong, you'll see that now that whole statement is red.
Yeah, there you go.
Because and it will tell you unknown name if I hold my mouse over it, LU run 1, that's incorrect. It isn't until I correct that that's actually right.
Yeah. Okay.
Okay. Good question. Thanks, Isaac. All right. We look forward to seeing you again, and we will talk to you later.